Hello, everyone. Thanks for joining us. My name is Shailesh Dwivedi. I'm responsible for product management and cloud engineering for Oracle Database Sharding. Today, we'll be talking about Oracle Database Sharding, which enables hyperscale, globally distributed, converged Oracle databases. We'll do a quick review of sharding. We'll look under the hood how it works, and as we go along, we'll talk about some of the new features as well as some of the very interesting and exciting things which are on our immediate roadmap. Sharding as a technology has been used by a lot of internet applications to scale their workload as well as provide high performance. We have taken the same approach and implemented sharding natively inside of Oracle database. What it is basically is a horizontal partitioning of data across independent databases. We call these independent databases as shard. It uses a shared nothing architecture. That means we do not require any specialized hardware or software to support it. And it also supports massive parallel processing. By that we mean able to like gather across multiple shards or nodes in this case. On the right-hand side, I'm showing three servers, three machines, server 1, 2, and 3. And on these machines, let's say we have a regular Oracle database instance. We call this whole Oracle database instance as a shard. So we have shard 1, 2, and 3. And on this shard, if you had a table called table 1, then the same table definition is present on all the three shards, and each table has a subset of data. So for example, if this table had 300 rows, we partition the data such that shard number 1 has row 1 to 100, shard number 2, which is in green, has row number 101 to 200, and shard number 3, which is in blue, has row number 201 to 300. So effectively, we take the data and we partition it across all the shards using a sharding key. An example of sharding key could be something like customer ID, and the data is distributed across all the shards. From application point of view, it looks like a single logical database. From operation point of view also, it looks like a single logical database. We have enhanced our application drivers, whether it's JDBC driver, C, Python, Go, etc. They understand sharding and data distribution, and the application automatically gets connected to the right shard where the data is residing for a given query. Additionally, we support massive parallel processing, where if we need data from more than one shard, then we have a query coordinator which pushes the query in parallel to all the shards and gets the results from the shard, aggregates them, and sends it back to the application as if application connected to a single logical database. Some of the benefits of sharding include it provides us linear scalability, and by that we mean that if we have to deal with more data volume, more transaction volume, we can horizontally scale by adding new shards, effectively adding new compute nodes. Additionally, it provides elasticity. So in case we have to take away some nodes, then we can do that as well, completely online without losing any data. The second big benefit of sharding is that it provides extreme availability. Basically, we are taking a big monolithic database and we break it into smaller nodes so that if there is any kind of impact on one of the node, other nodes are healthy and serving the traffic. There is no single point of failure in this architecture, but even if there is a small blip or a brownout, it only impacts a subset of data. The third big use case we are seeing where customers are adopting database sharding is for geographic data distribution. There are a lot of new regulations where a country-specific data or a region-specific data has to stay within a certain geographic bounds. What sharding allows us to do is create a single logical database where shards could be spread across multiple regions, thereby presenting a single logical database to the application, and the queries get routed automatically to where the data resides, and hence honoring the data sovereignty and data residency requirements. For hyperscale application, here is an example of one of our biggest sharded database deployment. This is our own Oracle BlueKai, which is a part of our customer experience Fusion Apps family. This application is able to handle 1 million transactions per second with Oracle database sharding. The total data volume for this application is 2.5 petabytes. It serves 30 billion API calls per day. Each API call has 125 kilobytes of payload. So these are not minuscule API calls. And with this data volume, we are able to achieve 1.6 millisecond read latencies and 2.5 millisecond average write latencies. The total number of rows in the largest table we have is over 22 billion. This application is a very write-intensive application, so it generates a lot of redo, and it's generating a redo at the rate of 180 terabytes per hour. It's running in our cloud over 52 compute instances, and these are very big machines. Each compute instance has over 50 plus cores. So if you look at cumulatively, we have a single logical database with 2,704 cores and over 38 terabytes of memory. Now, some of the key use cases why customers are using Oracle Sharding, and they did consider many other products which I have put on the right side of this table, and chose Oracle Sharding for their workload. So there are applications which are internet scale online transaction processing applications. Examples would include banking applications, payment processing, mobile to mobile transfer, marketing, healthcare, etc. The other category of application, as would be obvious, are those which need to comply with data sovereignty. Again, in financial industry, healthcare industry, there are a lot of regulations which are country specific and require data to be stored in a specific geography. And that's where our customers are using Oracle Database Sharding for. Oracle Database is a converged database, so we can not only store relational data, but other types of data like text data. And when you combine Oracle text with the sharding, then we are able to achieve use cases for things like text search, fuzzy match, log analytics, log data, etc. And our customers are using sharding for those kind of applications. The other big use case we see is metric data, time series data, Internet of Things like application, where devices emit data with a very high speed, and this happens to be a very voluminous data. So customers are using sharding for that. Sometimes the payload come in as a JSON format, etc. So again, Oracle database, which converts database capabilities, is able to provide us these kind of functionality. Many of our customers are using sharding for things like machine learning, so anomaly detection being done inside database, right on the shard where the data for that, say, customer is residing. So those kind of use cases are also enabled with the database sharding, things like fraud detection applications. And then big data analytics. As I mentioned before, we not only can partition the data, but query across all the shards. So this allows us to do pretty much a real-time big data analytics use cases as well. These customers considered many other products, and they chose to use Oracle Database Sharding because the applications require transactions, joins, data consistency, ACID properties, full support of SQL, cross-region replication, parallel queries, backup and recovery, triggered stored procedures, so on and so forth. So the schema continues to live inside of database rather than application building this functionality in the application tier. So our customers are able to scale like many NoSQL products, but without compromising on any of the core capabilities of a mature RDBMS. Let's look at how it works under the hood. In this diagram, I'm showing three tables: customer, order, and line item. We call this as a table family. And of course, we can have thousands of tables, but just for the sake of discussion, let's assume we have three tables. So in this set of tables, let's assume we are sharding the data by using a key, which is customer ID. So on the right-hand side, we have three shards, and each shard has a subset of data. So all the data for Mary, which is customer ID 123, which is in red, is located on shard number 2. All of Peter's data, which is blue, is located on shard number 1. And John's data, which is John's customer information, order information, line item, is all co-located on shard number 3. So with this, we route the application query directly to the shard where the data is residing. And what we want to do is push as much work as we can to the shard so that the joins across different tables get satisfied locally on a given shard. We also has a notion of something we call as duplicate table, and we can think of them as a reference table or dimension tables. And for these set of tables, which are declared as duplicate table, the data is replicated across all shards. So if you want to run a join that show me all orders or line items for Mary, that query gets satisfied on shard number 2. And if I want to see, show me all the products which Mary bought and the product being represented as a duplicate table, then that query also gets satisfied on shard number 2. At runtime, the shards don't talk to each other at all, so that gives us a nice linear scalability. Under the hood, the data is stored in a shard as a set of chunks. And so chunk number 1 here, for example, has data for customer 1 to 1 million, their order and line item. Chunk number 120 has data for customer 5 million to 6 million, their order and line item. And then we have the duplicate table data as well. So that's what a shard looks like. From an application request flow, we have 2 modes of routing. One we call as direct routing, where if the application knows the sharding key and is a part of the query itself, then our drivers route that query directly to the shard where the data is residing. So for example, we went to do a select star from customer where customer ID 1 and customer ID 1's data is located on shard number 1, then that query gets routed directly to the red shard. Additionally, we have a proxy routing mechanism as well, which is what allows us to do multi-shard queries. So in this example, I'm showing if you run a query, which is select star from customer and customer data is spread across all the 3 shards, red, green, and blue, then we have a query coordinator, which pushes this query in parallel across all shards. Each shard runs the query on subset of data it has. The results are returned back to the coordinator, which takes another pass as the data and does, in this case, it'll do a simple aggregation, but it could do joins, union, sort, merge, and whatever is needed. And then the results are returned back to the application as if application connected to a single database. From a deployment point of view, we have a few components. One, of course, we talked about the application and the connection client routing, which are the 2 methods, direct routing and proxy routing. We have another component called shard director, and we can think of this as a database connection router. So if I have 1,000 shards, that doesn't mean my application has to have endpoints of 1,000 shards. It just has endpoints of the shard director, which I could have 2 or 3 for high availability purposes. And then the application queries get routed automatically to the right shard. The third component is called shard catalog, and that's our metadata store, which stores the information about all the shards we have and the data distribution. This catalog also serves as a multi-shard query coordinator, and the gold image of the schema definition as well as the duplicate table data is stored on the shard catalog. Now, how do we partition data? We have many ways of partitioning data. One we call a system managed sharding, and here we use a simple consistent hash algorithm which is publicly available. And using that hashing algorithm, we distribute data uniformly across all shards. So this is what we call as a system managed sharding, where customers don't have to worry about fine-grained data placement. And as we add shards or remove shards, the system automatically rebalances the data without losing any data or compromising any of the capabilities. The second method for sharding is called user-defined sharding, and there we have 2 mechanisms. One is range, other is list. So range was the example I was using earlier, that customer ID data for customer 1 to 100 is on red shard, 101 to 200 is on blue shard, and so forth. Versus list would be that if we want to shard by customer state of residence. For example, if customer state of residence is on East Coast, somewhere in New York, New Jersey, Florida, put them on an Ashburn data center, versus if customer state of residence is on West Coast, like Arizona, California, Oregon, put them in a data center, Phoenix data center, which is on West Coast. So that's an example of list-based. Composite sharding is another very unique feature to Oracle database sharding. Here, we can shard the data by 2 different sharding keys and 2 different sharding methods, which is first level of sharding could be by range, followed by consistent hash, or list followed by consistent hash. In 23C, which is the new version of Oracle database which is coming out, we have introduced a new method of sharding, which is fairly fine-grained sharding, and it allows customers to flexibly map individual sharding key to individual shards. And this mapping can be actually changed at the runtime, and that results in the underlying data movement, and the system takes care of that automatically. Now, let's look at some of the operations and management capabilities. Another cool, very good feature we are introducing in database version 23C is a Raft replication. What this allows us to automatically configure replication across all shards without requiring any external replication tool. So we don't read things like a data guard or golden gate, but declaratively we can configure a replication factor, and with that, the system ensures that those many replicas of data is available at any given point of time. Additionally, if one of the nodes were to go down, the failover is instantaneous, and all nodes are active at all the time, so there is no notion of primary or standby. And as the number of shards are changed when you add new shards, we automatically reconfigure the system to honor the replication factor. There are other ways to do high availability and disaster recovery in addition to the Raft replication, which I just talked about. We can always use things like data guard and golden gate with sharding to replicate our data, which gives us full replica of the data. We can also use Oracle RAC technology if we want to. As I said before, sharding is a shared nothing architecture, but we can mix and match Oracle Sharding with the Oracle RAC technology, in which case each shard could be a two-node RAC cluster. This is how some of our biggest customers run in production as well, and that provides us a protection, instant protection from a node failure. We can do, sharding allows us to do active-active multi-region configuration. So in this picture, what I'm showing is that we can have some data which is primary on the left-hand side versus in region 1, and other data which is primary on the right-hand side in region 2, and application requests can seamlessly get routed to the right region. And the data is replicated using data guard within the region and across region. Local replication with synchronous local replication, cross-region asynchronous replication. We can also leverage Golden Gate, which allows us to do bidirectional active-active. So if you have two regions, region 1 and region 2, each region has full copy of data, so requests could be sprayed to either of the two regions, and Golden Gate ensures shard level replication across two regions. And within a region, we can also configure a local data guard to provide us additional protection from any local outage. We can add more shards, remove shards, and in this picture, if we had 3 shards and we added a 4th shard, then we have the ability to system automatically rebalance the data, and in this case, chunk number 4, 8, and 12 automatically get moved to the newly added shard. All shards get rebalanced, and this is a completely online operation, does not require any downtime. Exadata is the best platform to run sharding. With sharding, we benefit from Exadata capabilities like query offloading to storage cell, persistent memory, in-memory, hybrid columnar compression, etc., as well as the RAC cluster where in Exadata also can provide us protection from an immediate node outage. We also announced a Kubernetes operator for sharding, which enables us to do rapid provisioning, monitoring, elasticity. And if you're using Kubernetes as your tool for CI/CD pipeline integration, then we can easily use Oracle Sharding with that as well. Enterprise Manager Cloud Control has been enhanced for monitoring of sharding, so it has deep understanding of shards, keys, which are active, which are standby, how many chunks we have, which shards are running hot, where we need to add more capacity, etc. And we can easily create alerts, notifications on all these sharding level metrics. We also added a new functionality to do a major version upgrade, say from going from 19C to 21C, or from 21C to 23, by adding new shards and moving the chunks. So the flow is like you add an empty shard, move data online without any downtime from old version to new version of Oracle database, and then decommission the old shard. So this gives us an ability to upgrade our databases without any downtime. We also have added automation to do centralized backup and recovery. So by running a single command, we can take a consistent backup across all shards and then recover one shard or all the shards if needed. We force a consistent SCN across all shards, and that's how it allows us to do a consistent backup across all shards. For migration to sharding, if you have a database you want to migrate, then we have some toolings called Sharding Advisor. And then we have to add a sharding key, partition our schema. We have tools like Data Pump, Golden Gate to migrate data. And starting 21C, if it's a Java application, there are no application side code changes needed, and the application can just continue to run with a new sharded database. We are also announcing a new service we are working on, which is sharding with the autonomous global database. So it's called Oracle Autonomous Global Hyperscale Database. And what this allows us to do is to create sharded database on top of autonomous across the globe. So for example, I can have some shards in US, some in Europe, some in Asia. These are all running on autonomous databases, which provides complete automation for database manageability and tuning and operations. And from an application point of view, it will look like a single logical database. So Oracle Sharding, in summary, provides us extreme scalability and availability like NoSQL. It provides the converged database capability like relational data, JSON, text, spatial graph. All of that can run with sharding. Customers can continue to use SQL and other programmatic interfaces which they are familiar with. We provide strict data consistency, zero data loss, full support for ACID transaction, two-phase commit, complex join, trigger, stored procedures, parallel processing, columnar, partitioning, sub-partitioning, security, all the good things which you're familiar with. You don't have to compromise on any of that and scale your databases. Database sharding is often available to customers at no extra cost. It is already included in the Enterprise Edition license of the database, and most of our customers already have skills and tooling to program, deploy, and operate Oracle databases. So in summary, Oracle Sharding enables hyperscale, globally distributed database. It can be used with both structured and unstructured data. It can be used for both online transaction processing and analytic workload. It is included as a part of Database Enterprise Edition, and you probably have it, so please use it. Here are some additional resources and links to look at if you want to explore more. There is a live lab. If you want to try that out, that is available in Oracle Cloud for free of cost, which you can prototype and use sharding and get started with sharding. Some additional resources in our documentation and our page. And thank you very much for your time, and have a great rest of the event.